Welcome to my class. I'm Drew Collop. In today's class, we're going to talk about simplifying fractional expressions. In this course, you should have some experience simplifying fractions. Now we're going to add in variables. Many of the techniques you learned earlier will be directly transferable for simplifying fractional expressions. Let's review how to simplify fractions. So fractions can be simplified many different ways. First of all, we can divide both the numerator and the denominator by the same number. We've done that before when we simplified our fractions, but now we can divide it by the same variable. We can cancel out numbers or variables if that value is multiplied by both the numerator and the denominator. Very important, it has to be in both. Finally, if you have many terms throughout the numerator and the denominator, you can cancel those values out, the numbers or variables, if it's present in every single term in both the numerator and the denominator. To try and prevent you from canceling values out that shouldn't be, I would advise you to factor it first, then cancel it. So the last two lectures were all about factoring. So what we are going to do here is we're going to factor first and then cancel terms out. Let's look at our first example. What I want to do first is I want to look at my terms on the top, and I want to pull out a common factor. Remember, when factoring, always try and take a common factor first out. What's my common factor between 3x and 6xy? My common factor is going to be 3x. So I can pull a common factor of 3x out of the top. When doing that, that leaves me with 1 plus 2y. On the bottom, I'm also going to pull out a 3x. In doing so, that will leave me with 3z. Now that I have 3x on the top and 3x on the bottom, they cancel each other out. Now that they've canceled out, it leaves me with 1 plus 2y divided by 3z. This is your final answer. Now remember why this cancels out. Remember what happens here. Let's do a little extra step in between. 3x times 1 plus 2y divided by 3x times 3z. That's what we have down below. But what I can do is I can split these up into two separate fractions. You can see those things are exactly the same thing. What do you see now? 3x divided by 3x. This is just equal to 1. That is why these cancel out when you have the same values in the numerator and in the denominator. That one was pretty easy, but you should always try and do common factoring first. It's not always going to be common factoring that works, though. Again, your goal should be try and factor first, then simplify. Remember the tools you have to factor. You have common factoring, you have difference of squares, you have factoring a simple trinomial, you have factoring a complex trinomial, and you have substitution. Let's look at a more challenging example right here. Simplify this fraction. Now initially, when you started this course, I bet you would have done this. But of course, this is incorrect. Why? Because it's not in all terms, so we can't do it that way. Perhaps before you went over how to factor, you would have no idea how to simplify this fraction. Let's see what we have here. Here, this is a difference of squares. And here, our coefficient on our second degree term is 1, so this is a simple trinomial. And hopefully you remember how to factor that now. Let's do that. Let's apply difference of squares to our x squared minus 25. Here we get x plus 5 and x minus 5. We then divide that by, what are we looking for here? We're looking for two numbers that multiply to negative 10 and add up to 3. Those two numbers will be 5 and negative 2. 5 times negative 2 is negative 10. 5 minus 2 is 3. We can now factor this as x plus 5, x minus 2. See what happens here now? We have x plus 5 on the top and x plus 5 on the bottom. They cancel each other out, leaving me with x minus 5, x minus 2. That is the final answer. Remember, you can't cancel these x values out. Why? Because these values here don't have the x. Sometimes I refer to this as being canceling crazy. Students they just try and cancel everything out. You can cancel values out, but only if you have that same value in all terms in the numerator and in the denominator. So please be careful of that. The way you can avoid making this mistake is always factor first before canceling. Let's work through some more examples here. B, we have x plus 1. There's not much I can do there in terms of factoring, so I'll just copy that down on the next line. On the bottom here, though, notice we have a simple trinomial. Looking for two numbers that multiply to 2, and those same two numbers should add up to 3. Those numbers will be 2 and 1. So we can factor this as x plus 2 and x plus 1. What do you see now? We have x plus 1 on the top and x plus 1 on the bottom. They cancel out. X plus 2. Now what do I put on the top here? When I cancel x plus 1, what is the value on the top? Remember, it's 1. A lot of times students make a mistake and they put 0 there. Please don't make that mistake. So this simplifies down to 1 over x plus 2. That wasn't so challenging. Let's look at C now. C, looks like we have two complex trinomials. Can we take out a common factor? We cannot. Now once again, be careful. I've seen many a student do something like this. That cancels that, and that cancels that, and that cancels that. So this is 3 over 2. Incorrect. Why is that incorrect? Because to cancel values out, every term in the numerator and in the denominator has to have that same number or that same variable. So here we have two complex trinomials. The first one here, we're looking for two numbers that multiply to 2 times minus 3 is minus 6 and add up to negative 5. This one here is also a complex trinomial. I'm looking for two numbers that multiply to 2 times 2 is 4 and add up to 5. Two numbers that multiply to negative 6 and add up to negative 5. We have negative 6 and positive 1. Two numbers that multiply to 4 and add up to 5. We have 4 and we have 1. So now that we have that, we have to decompose that middle term in both the numerator and the denominator. We get 2x squared plus 1x minus 6x minus 3. On the bottom now, we get 2x squared plus 4x plus 1x plus 2. So I've tried to color code it to show you where these values are coming from. So we've decomposed the negative 5x into positive 1x and negative 6x. We've decomposed the positive 5x into positive 4x and positive 1x. What do we do now? We group the first two terms and we pull out a common factor in both the top and the bottom. Pull out a common factor here of x, 2x plus 1. Pull out a common factor here of minus 3, 2x plus 1. On the bottom here, we pull out a common factor of 2x. We get x plus 2. We then pull out a common factor. Remember, we have to pull out a common factor. We can always pull out a positive 1. In doing so, we have the same value here and here, and here and here. Again, you should get that. If you don't, you've done something wrong. This then becomes 2x plus 1 times x minus 3. Divide that by 2x plus 1 x plus 2. How do we cancel now? We have the same value of 2x plus 1 on the top and on the bottom. So they cancel each other out. Leave me with x minus 3, x plus 2. Final answer. So that whole thing from the start distills down to x minus 3 divided by x plus 2. You might wonder why we're teaching this. Honestly, you won't use any of this in the laboratory. However, next semester when you're taking calculus, you will use this quite a bit. So to understand calculus, you must understand how to factor values out and simplify fractions. You'll understand in your next math course. Let's try D. We have a complex fraction. We have a fraction within a fraction. So first thing we should do is always try and pull a common factor out first. So let's do that first. We're going to pull a common factor of 3 out of the top. A squared minus y squared on the bottom here. We can pull that divided 3 out by making it a coefficient of 1/3. See what we have here now? We have a difference of squares. Let's factor that. And what do you see here now? We have the same value on the top and the bottom. They cancel each other out. This leaves me with 3 times a minus y divided by 1/3. Now remember, when I'm dividing by a fraction, what do? I flip it and I multiply it, leaving me with 9 times a minus y. And if I wanted to, I could remove all of my brackets. 9a minus 9y. Final answer. So here we are taking our knowledge of factoring, our knowledge of fractions, our knowledge of canceling, and we're combining it all together to simplify these fractional expressions. That's all the lesson for today. The remainder is for you to practice on. We have a large number of practice problems. In practice number 1, I'm just asking you to simplify. In practice number 2, you can see we have 2 fractions, either multiplying together or dividing together. So combine those fractions and then simplify. 3a, we have a complex fraction here. There is no variables in this. It might be a little easier to practice with, but B and C, specifically C, is very challenging. C, I will not be giving you a question like that on any assessments. Let's just say if you can solve C, you can do any of these problems. So give that as a challenging problem for yourself. As always, I have the answers written at the bottom. But the answers are not the solutions. You have to know how to get from the start to the finish. This is just the finish. I'll take some of them up, and the ones I don't take up, you're welcome to speak to me outside of class or ask me during tutorial. Let's do some from practice 1. I'll scroll down, we'll do a number of them. Let's do 1c. 1c is what? X minus 1, x squared minus 1. What do you do now? Tricky part here is, remember, I can take the square root of 1. It's just going to be 1. So I can factor that as x plus 1, x minus 1. These cancel each other out, leaving me with 1 over x plus 1. Final answer. Not too challenging, but remember, we can always take the square root of 1. It's just 1. Let's do D. Negative 2x minus y divided by y minus 2x. How do we do this one? This one's easier than you expect. That negative sign there, let's make it negative 1 over 1 times 2x minus y over y minus 2x. These two things are equal, right? So what I'm going to do, I'm just going to distribute my negative sign to the top one. The reason why I wrote it as negative 1 over 1 is because we can only distribute the negative sign either to the numerator or the denominator. I would not distribute it to everything inside. This will then give me negative 2x plus y over y minus 2x. Let's rearrange that. Y minus 2x over y minus 2x. What do we get? Same thing on the top and the bottom. What is this equal to? It's not equal to 0. It's 1 over 1 or just equal to 1. Let's try e now. A bx minus b squared x over acx minus cx squared. Let's pull out common factors from the top and from the bottom. So common factors from the top, I have a b and an x. A minus x. On the bottom here, I can pull out a c and an x. A minus x. What do you see now? I have the same value on the top and the bottom. They cancel each other out. This leaves me with bx divided by cx. And again, we have the same value on the top and the bottom. These cancel each other out. And my final answer here, b over c. Let's do h. Let's pull out common factors from the top. We have 6 as a common factor, and we have a c, leaving me with 3a squared. Over here I have just b. On the bottom, I can pull out a common factor of 14. And I can also pull out a d. 3a squared minus b. Look at that. These cancel each other out, and I'm left with 6c divided by 14d. Can I factor this anymore? I can. I can pull a 2 out of the top, and I can pull a 2 out of the bottom. I factor it first, and then I cancel those factors. 3c over 7d, final answer. So these are the questions from practice 1 I'm going to take up. The rest try on your own. If you have problems, we can talk about it outside of class. Let's try some problems from number 2. Let's try 2c. What's 2c now? It's a big one. First step here, what do I have here? I can see I have a difference of squares right here. So let's factor that out. X squared plus y squared times x squared minus y squared. We can combine this all together as one big fraction. This would be times ax cubed. On the bottom here, I would get a squared x squared multiplied by, this is a sum of squares. Remember, this does not work the same as a difference of squares. So just keep that as x squared plus y squared. Notice what we have. We have the same value on the top and the bottom. They will cancel each other out. I will then get x squared minus y squared, ax cubed divided by a squared x squared. Let's pull a common factor from the top and the bottom here. I have a common factor of, I have an a and an x squared on the top and the bottom. If I take that out, I get x squared minus y squared, and what remains is just x. On the bottom here, I take out an ax squared. What remains is just an a. These then cancel each other out. I'm left with x times x squared minus y squared divided by a. Let's distribute my x to get rid of the brackets. And that's as far as we can take it. Let's do g. G looks like a good one. This is a good one because it has simple trinomials, complex trinomials, and difference of squares. Wonderful. Let's give this a try now. A lot of work here. So our simple trinomial, we're looking for two numbers that multiply to 6 and add up to 5. Our complex trinomial, looking for two numbers that multiply to 2 and add up to -3. And over here, another complex trinomial, we're looking for two numbers that multiply to 6 and add up to -7. Two numbers that multiply to 6 and add up to 5, we have 3 and 2. Two numbers that multiply to 2 and add up to -3, -2, -1. And finally, two numbers that multiply to 6 and add up to -7, we have -6 and -1. So I'm going to factor my simple trinomial, my complex trinomial, and I'm going to use my difference of squares on these terms here. So simple trinomial, pretty easy to factor. Complex trinomial, we have to decompose that middle term. Divide that now by difference of squares, x plus 3, x minus 3. And on the bottom here, we have to decompose that middle term again because it's a complex trinomial. Let's group those, and take out common factors. Two x comes out, x minus 1, -1 comes out, x minus 1. Common factor here, just an x. Let's take those factors out. Can we simplify this? We can. I have an x minus 3 and an x minus 3, so they cancel each other out. That's all I can do up to this point. Now let's apply our division symbol. When we're dividing fractions, what do? We flip it and we multiply it. Turn our division symbol into multiplication, and we will flip our fraction. Now what do you see here now? I have an x plus 3 on the top and x plus 3 on the bottom. I have a 2x minus 1 on the top and 2x minus 1 on the bottom. All this simplifies down to x plus 2 divided by x plus 1. Final answer. This is a great question. It tests your ability how to factor using difference of squares, simple trinomials, complex trinomials. It tests your ability to pull out common factors. It tests your understanding of dividing of fractions and canceling out and simplifying. That's a great question. From 3, I'm just going to take up b. What was b? 4a squared minus 4x squared divided by a plus x divided by a minus x. So we have a fraction within a fraction. Let's start by writing it this way. Means the same thing, right? Let's now flip it and multiply it. Let's pull a common factor out from our first set here. 4 comes out, leaving me with a squared minus x squared. Notice what we have here? We have a difference of squares. So let's factor that using our knowledge of difference of squares. If we're multiplying these together, this would be a minus x here, and on the bottom here, this would be a plus x. right? We can turn that into a fraction, multiply them together. Cancel values out, a plus x and a plus x. In the end here, 4, a minus x, a minus x. We could combine those together, 4, a minus x squared. Alternatively, we could say leave no brackets, so this would be 4 times a squared minus 2ax plus x squared. Lastly, we have 4a squared minus 8ax plus 4x squared. So this is fewer values, but this is the same thing, but no brackets. During these last few lectures, we've talked about factoring. Common factoring, factoring using difference of squares, factoring using simple and complex trinomials, and factoring using substitution. In this lecture, we used all that knowledge and our knowledge of fractions to simplify fractional expressions. These are only expressions. They're not equal to anything, so we can't solve for any of our variables. In our next lecture, we're going to talk about quadratics. That's when we have a trinomial and it's equal to a value, in which case we can solve that. We'll solve it by moving all of our values to one side, setting the other side equal to 0, factoring, and then finally solving. That's all for today. Until next time.